Okay, one last video, the hydraulic lift, which is basically what we're creating. Our pneumatic or our hydraulic systems are going to need to have an analysis of how much force we're applying, and we can do that by taking a look at some of those pressure practice problems. It is going to be something that I'm going to require you to know how to do when we get to our final exam on this. So please study this carefully. You are going to be required to show me you can do it in a couple of different ways. So let's make sure that we go through this completely. I can't show you my computer screen because I'm recording on it, so I'm going to just quickly go back and read and then kind of identify some of the pieces and parts. The very first thing I'm going to do is write down the equation. All right, we have P is equal to F over A. And I'm also going to write down the information and go through it with you. So equation and information. I'm going to do number 1 on the assignment for March 1st. So if you don't have that one done yet, you do need to get credit for it. So please make sure you are following this guide to help you do number 1. You don't have to do number 2. Please complete number 3. So the information that we have is a hydraulic lift whose input line has a cross-sectional area of 1.00 centimeters squared, so I'm going to put 1.00 centimeters squared, and output line, so that's going to be my input area. My output line has an area of 20 centimeters squared, so that's my area output, and I'll show you this in a second when I get done reading. 20.0 centimeters squared, and we have an input force of 1,000 newtons. The question is our output force, and that's going to be a question you see quite a bit. So let's take a look here at what I have written down, and let's do some figuring. All right, so let's see. Pretty bad glare the last time. Information we have, we know our A input, our output, our force input, and our force output. We also know this equation. There's also a law for Pascal, and it says that your pressure, your input pressure, is going to be the same as your output pressure. So your P in is going to be the same as the pressure out. All right, now we're just going to go and write down how we calculate this. All right, let's make sure that this is legible. There we go, that's better. So we're going to say F in over A in, and this is just, we're just rewriting this, is equal to F out over A out. Okay, now we can go back and see we have out, in, and out. So we can substitute in as much of this as we possibly can. Okay, our input, let's see, substitute. Can we see? Gosh, I hope so. There we go. When we substitute F in, we know is 1,000 newtons. We're going to have that over our A in, which is 1.00 centimeters squared. That's going to be equal to F out, and we don't know that, so we're just going to call that F out. That's what we need to solve for. Okay, and A out is 20 centimeters squared. Great. Now we need to solve. This is all set up correctly. The nice thing is, if you don't know one, you can find it. There are several ways to solve, so let's take a look here. You can solve this first by cross-multiplying if you would like. So one method is cross-multiplying. And that is when you say you have, oops, can you still see? There's too much glare. Okay, we have 1,000 newtons over 1 centimeter squared is equal to F out over 20 centimeters squared. when you cross multiply, you're basically rewriting your equation and you're setting things equal to each other. Alright, so I want to set one side equal to the other. So my one side here will be equal to this side here. I have f times 1 centimeter squared, which is great because that's just f out times centimeter squared. My n is 1,000 times 20, which is 20,000 newtons times centimeter squared. Alright, so I have 20,000 newtons times centimeter squared is equal to f out times centimeter squared. To get f out by itself, I get rid of my centimeter squared by dividing it. Centimeter squared divided by centimeter squared. Anything divided by itself is equal to 1. So you see here, this is also equal to 1. My final answer is 20,000 newtons is equal to my output force. So that means that I can actually have this output force of 20,000 newtons. And what this really looks like, and you see that there's a picture right below, and I'm sorry, I should have drawn this first. And you have your system like this, and you have a much larger area. Remember, Pascal's law says that when you confine, when you basically make a closed system, so this is closed, and it's hydraulic, the pressure will be the same everywhere throughout the fluid. So I have an input force over an area, my input area, and I end up with an output force over a different sized area, or it can be the same area, then it would be a direction multiplier. This is called a force multiplier. Okay? And a force multiplier will actually take a very small force, just like when I use my brake. So it'll take the small force from my foot and it will turn it into enough force to actually stop my giant minivan, which is great because then I don't run into anything. I want to come back up here, and again, this is considering the pressure over here and how it's equal to over here. I can do this another way. I can come back up here, and what I can do is solve algebraically. So number one, here's my second method. I can use algebra. Alright, so again I have 1,000 newtons over 1 centimeter squared is equal to my output over 20 centimeters squared. In the event that I want to undo this division here, because I want to isolate f out, I must multiply by the same thing. So I take 20 centimeters squared, and I have to do it to both sides. Alright, you notice here I end up with 20 centimeters squared over 20 centimeters squared. Anything divided by itself is equal to 1. And here, what I end up with is centimeters squared divided by centimeters squared. That also equals 1. Now I have 20 times 1,000 newtons divided by 1. 20 times 1,000 is, again, 20,000 newtons over 1. I don't really need it. So again, I've ended up with the exact same answer. I've gotten there in a different way. It's the same. The third way that I can do this is really go through and first find out the pressure over here. Alright, so I can say, what is the pressure here? And then use it here. So my pressure first will be 1,000 newtons divided by 1 centimeter squared. You see that equals 1,000 newton per centimeter squared. That is my input pressure. So that down here is P in. This is P out. Okay. All right. Then what I can do, you go back and you take a look, it is asking you for the force, the output force. I have an equation for force. I can find it by doing this. My force divided by my area is equal to the pressure. Now you notice It's kind of dark. If I want my force, I cover up that and I have an equation. It's pressure times area. So my output force is going to equal to pressure times area. When I come back here, I have my pressure. It's 1,000 Newton per centimeter squared. And I have my area. My output area is 20 centimeters squared. So this is all output. I know my output pressure is the same as my input pressure. So that's why I'm using it there. Now, my P out is 1,000 Newton per centimeter squared. And I will multiply that by my 20 centimeters squared. Again, we have centimeter divided by a centimeter. That becomes 1. 1,000 times 20 is equal to 20,000. I am left with newtons once more. That is the third way you can get your exact same answer. So we do have 3 different methods to go about solving for the exact same thing. Whichever one makes the most sense to you is correct. Please make sure you hang on to your units. We are going to be working on this at length while we are building our robot, so it's important that you understand this. Wonderful. Do number 3, not number 2. You can skip that one, okay? Good night.